All right, so I didn't finish page 111 as I was rushing to try to do so on Friday. So this is just going to be a quick video on the last two pieces that we hadn't gotten to yet. So first thing I want to point out is that I kind of rushed through this calculation here. This is how we calculate that margin of error like we saw in the CNN example. It's comprised of two pieces. Our Z star, which tells us basically how many standard errors that we want to go out, and then a standard error, which is like the brother of our standard deviation. So it's not a standard deviation, but you remember the standard deviation for p hat looked very, very similar, right? PQ divided by N. So the standard error has a similar feeling, but a different definition. I won't get into it because I already made this video twice, and the first time it was like 10 minutes long, and I'm trying to avoid that. So I do want to point out, though, that your formula sheet has the confidence interval for a proportion. This entire calculation is there. It does break down into three pieces. We have our point estimate. So if we just had to estimate the true proportion with one value, we would just use the sample proportion. It has our critical value, which is all about how far away we want to go in terms of standard errors. And then we have our standard error. And I have put standard error as a test question before, and then no one actually gets that question right because no one remembers that that is the standard error. So what is the new stuff besides this formula? Well, oops, that's not the thing we want to go to. Two pieces. One is the idea of what a confidence level tells us. It doesn't truly tell us the probability of catching the real value because the real value is not a random event, and probabilities only apply to random events. And so since it's not random, it is just an unknown item. We can't use the word probability. We shouldn't even use the word chance, which I used when we were talking about the confidence intervals we made. But it does tell us if we did this a whole bunch of times. So let me pull up StatCrunch really quick. If I made a ton of confidence intervals, which is what I was hoping we would have time to do in class on Friday, but we were running a little bit at a time. So we counted up the number of even dice rolls. So we were dealing with something where our P was 0.5. And we made sure our sample size, we didn't end up using 30, we used 25, right? I'm pretty sure we did 25. And then let's make our confidence level 90. If I were to do this, StatCrunch can go out and do exactly what you guys are doing, except for it does it for 100 things, whereas we only had 26 because that's how people were in class on Friday. So you can see what happens. This is exactly what we did in class. We have a bunch of green intervals, which were blue, and a bunch of red intervals. So a red interval is one where, as it was sampling data, we ended up with 17 out of 25, so a very high proportion, and our interval ended up not catching the real value of 50%, even though we created these values from that. So you can see here, when we did this, 89 of these intervals contained the real value, which is really close to our 90%. And that's what the 90% actually means. Is if we were to do this a whole bunch of times, we'd expect around 90% of the intervals to contain the real value. So that's the whole purpose of our confidence level. Now, we never know, because we've only got one sample, whether we're a green interval or a red interval. We don't know if we've actually caught the real thing, which is why we use that word confident. And your first introduction to why statistics is an evil subject, because we never truly know if we're right or wrong. So the second thing that we didn't get to are our assumptions and conditions. And we can go through these really quick because you've seen them all before. The assumptions and conditions essentially all come down to the fact that we need to be able to use that Z star, right? And when can we use a Z star? Well, we need to have at least approximate normality. So all of these are the same things you saw in 6.1. We still need independence, we'll still need an SRS, we still need our N to be less than 10%, and we still need to meet a rule of thumb. Here's the only difference. In our original problem, right, when we were in 6.1, 1, we looked at NP and NQ both being greater than or equal to 10. But now when we're making a confidence interval, we don't truly have P, right? We don't know what that is. We're making a whole interval to guess what P is. So the only difference between the assumptions and conditions necessary to make a confidence interval from those necessary to use the approximate normal in section 6.1 is that now it's going to be P hat and Q hat. So this is, instead of the expected number of successes and failures, the observed number of successes and failures must be at least 10. So there you go. That's everything you need to create a confidence interval.